What is up, everybody? Time for Odysseyware video number 4. So we basically finished up the Intro to Waves unit in our last video, and we're going to go ahead and move on to the electricity unit. Static electricity, to be specific, so the lesson we're looking at right now is static electricity. And we're going to be talking a lot about charges and about atoms, and we're going to be talking about how things become charged and when do they attract and when do they repel. This lesson is actually one of the more accessible ones. I think you guys can handle a lot of the questions on your own, so I'm only going to be talking about a very small part of it. The first thing you guys are going to have to do when you actually go to the assignment is you're going to have a reading at the beginning that is going to talk about some historical figures in science. And this is definitely the kind of thing that you guys can read through and understand and answer the questions about. This is going to be up to you, all right? So you're going to learn about William Gilbert and his sort of discoveries of static electricity, which went totally unrecognized and undescribed by science for a very long time. And you're going to learn about Benjamin Franklin, who, believe it or not, did actually contribute significantly to the science of static electricity in his off time when he wasn't, dealing with politics and the American Revolution. What we're going to start with, where we're going to pick up, is this picture right here. We're going to look at this picture. That is a picture of an atom. And so I'm sure you guys learned in junior high school about atoms, but I want to remind you one more time, because I think we're actually talking about it less and less in junior high, and it's becoming more of a high school requirement. So if you're looking at that going, I don't really know what an atom is, yeah, it's probably not your fault. Maybe your teacher just didn't talk about it. So atoms are the smallest kind of thing basically in the world. It's sort of like the building block of everything. You are made of enormous numbers of these tiny little things called atoms. And they have two main parts. All right, the first part that you're seeing in blue here is what we call the nucleus, the middle of the atom. And the nucleus has like 99.99% of the mass of an atom contained within it. It is basically all of the mass. It is basically the solid part of an atom. And it is made up of two things. It's made up of protons and neutrons. Neutrons have no electric charge. And you can remember that because it is N for neutron and N for no. Neutrons have no charge. The official way to say that in science is that they are neutral. All right, so neutrons are neutral. That's how they got the name. And then the other thing in the nucleus, oh, by the way, we're basically not going to worry about neutrons right now because we're talking about electrical charges. And since neutrons are neutral, we get to basically ignore them. So you can totally forget I talked about them for right now until you come back and take chemistry, and then neutrons will become pretty important once again. Also in the nucleus, what we are going to focus on is a thing called a proton, and you can see that word written right here. A proton has a positive charge. Yes, they both start with the letter P. Proton and positive, they go together. So inside the nucleus, you have these positive charges. You can see these little positive plus signs right here that give the nucleus an overall positive charge. Now, on the outside of the atom, we have these things called electrons. Electrons are ridiculously small, have almost no mass, and they have a negative charge. They kind of fly around the outside of the atom, creating this cloud, and we're going to talk in more detail about how those electrons affect the material in a moment, but for right now, we just want to know that they have a negative charge and the nucleus has a positive charge. Okay, so that's going to be good enough for right now. Then we're going to go down to this next picture and we're going to talk about removing electrons and what that does. If you take, because electrons are on the outside, because they're on the outside, they are really the active part of an atom. They are the part that you're going to interact with, that is going to touch other atoms or, connect and exchange with other atoms. And so it's usually going to be movement of electrons that we're focusing on when we're talking about electric charge. In this case, we are removing an electron from the atom, okay? Electrons are negatively charged. So the atom is now going to be positively charged. Because if you look at it, we've got 2 positive charges in the nucleus. We have only 1 electron left. And so overall, there is a net positive charge of +1 because there is 1 extra proton than electron. So anytime you remove electrons, you create a positive atom over here. Now, where did that electron go? Presumably, that electron went to another atom that pulled it away. And so the other atom, the one that gains the electron, is going to become positively charged. Okay? All right, so now we're going to move to the whiteboard and we're going to talk about different kinds of materials and how things become charged. This lesson talks a lot about the situation of like clothes getting a charge in a dryer. And so what I want to do is kind of show you what's happening on an atomic level. It also talks about Gilbert doing this experiment with wool and his boot. It also, and like the rubber on the bottom of his boot, which totally works. It also talks about a very similar example that you might have done, which is rubbing a balloon on your hair. Gonna get really weird here for a second, but like your hair and wool, it's the same thing, right? Because wool is hair, and rubber in a balloon and rubber in a boot are the same thing also. So when we combine these 2 materials together, and we rub them together, then that is gonna create a charge. All right, let's show that with some atoms. All right, so let's say this is the rubber on Gilbert's boot, or the wool of, or sorry, this could also be like the metal of the dryer. And then over here we have the wool of Gilbert's coat. And what's going to happen is we've got these atoms with positively charged nuclei right there, and they've got some electrons, which are negatively charged, kind of whizzing around on the outside. And when they rub together, there's going to be an exchange of electrons. And the way that it works, I don't know actually which one becomes positive and negative. I'm not remembering that right now. Doesn't actually really matter. But what does matter is that there's going to be some exchange. I believe that what's happening is that an electron gets stolen from the wool and jumps over here to the rubber. All right, so now the overall charge of the rubber is negative. It has a -1 charge. And the overall charge of the wool is positive. Why did I write 2? I don't know. Don't ask questions like that. It's a 1. All right, and so what does this mean? A couple things. One thing that it means that's really important is that these are going to be opposite charges, and opposites attract. This is why the balloon sticks to your hair. This is what Gilbert noticed, was that his coat wanted to attract to his boot. So because of this exchange of electrons, these 2 atoms now attract, all right? Because 1 electron moved from one to the other. The other thing that we want to know is that these materials are, actually I'm gonna write that over here, so. That rubber in particular is a really good insulator, okay? An insulator is a material that holds strongly to its electrons. So that's why it's grabbing electrons from other things, and it does not allow electrons to flow through it. So if you try to run an electric current through an insulator, it doesn't work unless you use enormous amounts of power. This is why, one of the reasons, why boots have rubber soles. At least you're required in many places like construction sites to wear rubber-soled boots, because it protects you somewhat in the event of electric shock. If you were to touch something that's a live wire, electricity can't flow through into the ground because of your rubber-soled boots. It doesn't protect you completely. You're still going to get hit by lightning and like enormous voltages, but it does provide at least a little bit of protection. And so an insulator holds electrons strongly. I know that's hard to read. And it also does not allow an electric current to flow through it. Insulators also are going to be really good at getting a static charge, Okay, so rubber is really good at creating a static charge. Glass, plastic, these are all things that can create static charges because they're also really good insulators. Just so we know, the other thing that we will talk about sometimes is if we were to add metal over here. Metal is a really good conductor. Okay, conductors do not hold strongly to their electrons. They allow the electrons to flow in and out very easily. And the reason for that is metals have a lot of electrons that are kind of like way out here. They have like an outer layer. So here's my kind of inner layer of electrons. Maybe there's 2 electrons right there. And then they have this kind of outer layer that's like really far away from the atom. And these guys are held on very weakly. Okay, and so it's very easy for those electrons to be stolen by something like a greedy insulator over here. And it's also possible that if you apply an electric current to this, that these electrons very easily move along. And so conductors are what we build like wires out of, because they do not hold their electrons strongly and they can carry a current. All right, so read up on your science history and use this information to complete this lesson. Good luck.